Your do not for today is to help us get started with information we need from last week. So hopefully it felt easy and familiar. So on the first problem, it asks for you to find the inverse. Remember, we have a formula for finding the inverse. That's your A inverse equals 1 over the determinant times the matrix. Oh, I'm sorry. In a different order. That's a horrible color to see. All right. So on this one, the first thing I'm going to do is find the determinant. I'm going to call this matrix A as well, doesn't it? So the determinant is 2 times 4 minus 3 times 1, which equals 8 minus 3, which equals 5. So that means my inverse is going to equal all of this divided by 5, right? So 4 divided by 5, negative 3 divided by 5, negative 1 divided by 5, and 2 divided by 5. And you can leave it as fractions, or you can convert them to the decimals. And as decimals, you're working with 8/10, negative 6/10, negative 2/10, and 4/10. Okay, on number 2, this is just a reminder of symbols. When you just see a matrix with the bars, that means it's asking you to find the determinant of that matrix. So the determinant of, let's call this matrix B, is going to equal 3 times 5 minus 4 times 1, which equals 15 minus 4, which equals 11. Okay? Questions, comments, concerns about the do now? How we do? Good? All right. So today we are solving matrix equations, not solving matrices. I don't know why I'll stop. But we're solving matrix equations. So what we need to know about solving a matrix equation is if a matrix A has an inverse, you can solve the equation by multiplying both sides by the inverse of A, okay? So that's basically it. Using the inverse to solve the equation. So here are the steps that we're gonna follow. Step 1, we check that the determinant doesn't equal 0. If it does, then there is no solution. If it doesn't, then we proceed. 2, we find the inverse of the given square matrix. Okay, and we're going to multiply each side by the inverse. And then recall that a matrix times its inverse is going to equal the identity matrix. So that means it doesn't matter, it goes away because everything will cancel out. And your solution comes from X equals the 2 by 1 matrix. So in the end, you'll end up with a 2 by 1 matrix as your solution. All right. Okay, so I'm going to go. So here we have 5, 3, 3, 2, X equals 1, negative 3, and we're solving for X. So the first thing we have to do is find the determinant of this matrix. So this is what we're going to call this A. And we're going to find the determinant of A. So step 1 is what is the determinant of A? Well, 5 times 2 minus 3 times 3 equals 10 minus 9, which equals 1. The determinant is 1, not 0, so that means we're good to go, right? So step 2 is to find the inverse. Because my determinant is 1, that means that when I do the switch and the change the signs, so switch 2 and 5, change the signs of the 3's. Is there any point of me dividing by 1? No, because it's going to do what? It's going to be the same. So we follow that. Now it says to multiply each side by the inverse. Well, when I multiply 5, 3, 3, 2 times the inverse, 2, -3, -3, 5, x equals 1, -3. I wrote it backwards. Hold on. I can't do 2 by 1 first. I have to have the 2 by 2 first. 2, -3, -3, 5 times 1, -3. Well, this side is going to become the identity matrix. And anything times identity matrix is itself. And this side, I'm going to go through and do my multiplication. So I have 2 times 1 plus -3 times -3. Then I have -3 times 1 plus 5 times -3. So 4, x equals what? 2 plus 9 is 11. -3 plus -15 is -18. So that's what x would equal. Yes.
So right there, it's inverse for 5, 3, 3, 2. Or inverses. Let's say if it was a different number, would it not equal 1, 0, 0?
No, because then the step is to multiply by the inverse. And when you multiply by the inverse, what's going to happen? What does step 3 say is going to happen? It creates the identity. And anything times the identity is itself. That's why in step 4, x is by itself. All right. Good morning. All right. Okay, so let's try another one. So we're going to do another one, solving the matrix. So step 1 is to find, we're going to call this matrix A. So find the determinant of matrix A, cross multiply and subtract. So 3 times 6 minus -9 times -2 equals 18 minus 18. What does that equal? 0. So what does that mean? No solution. Womp, womp, womp. So as soon as that happens, what do? Stop. Do you all feel comfortable with what a no solution problem would look like? Okay. All right, here's one for you to do. So I'm gonna pause and let you try it following through with the step. So step 1 is to check the determinant. And we end up with 4 times 2 minus 3 times 2 equals 8 minus 6 equals 2. So it's not equal to 0, so that means we continue. So step 2 is to find the inverse. The inverse is going to equal 1 over 2 times. I switch along the main diagonal, and I change signs along the minor. So everything divided by 2. 2 divided by 2 is 1. 3 divided by 2 is negative 3 halves. Negative 2 divided by 2 is negative 1. 4 divided by 2 is 2. Step 3, I multiply everything by 1, negative 3, 2. Now I'm going to write it out, but in reality, do you really need to write it out on the right side, no, on the left side? No, because they're going to do the identity. I didn't mean to write it as a fraction. Okay. So this is going to equal the identity 1, 0, 0, 1. And this equals 1 times negative 5 plus negative 3 halves times 2. Negative 1 times negative 5 plus 2 times negative 3 halves. I did not mean to write that 2 times 2, Shauna. Okay, so step 4, that means x equals negative 5 minus 3, which equals negative 8, positive 5 plus 4 equals 9. How do we do? Good? If you made a mistake, do you see where you made your mistake at? Questions about the process? All right. So, system of equations and matrices. So we've learned previously that they go hand in hand, they're friends, right? So here is another way for us to solve a system of equation using the matrix equation. So when you are using this, basically you're taking your system of equation and you write it as a matrix equation. So you have your coefficient matrix, your variable matrix, and your constant matrix. And then once you set it up, you proceed to solve it just as we did before. So we're going to do an example of taking a system and turning it into a matrix equation and solving from there. So here we have the system, 4x plus 7y equals 6, negative 5x plus 3y equals 1. We're going to turn it into a matrix equation. We're going to have our coefficient matrix, 4, 7, negative 5, 3. We have our variable matrix, x and y. And we have our constant matrix, 6 and 1. Once we've made it into a matrix equation, then we're just going to follow the steps that we were following before. So step 1 is we find the determinant. And we're finding the determinant of the coefficient matrix. So that's 4 times 3 minus 7 times negative 5, which equals 12 plus 35, which equals 37. 47. Yes, I did. I added 2 and not 12. Okay. Step 2 is to find the inverse. Remember, the inverse is 1 over your determinant. You switch along the main diagonal, change the signs along the minor. And we're just going to leave it as fractions. So my inverse equals 3/47, negative 7/47, 5/47, and 4/47. 3, I multiply both sides by the inverse. I know that on the left side, I'm going to be left with the matrix. And then on the right side, I'm going to have to do some math. It's not a very pretty fraction. I let it be on purpose. Little fraction practice never hurt anybody. As long as you just leave it as a fraction. And it's nothing wrong with it. I don't know I wrote it that way. So we're keeping the exact value the entire time. When you have a whole number times a fraction, remember it's just the whole times the numerator, right? So our answer is 4. 3 times 6 is 18. Negative 18 plus minus 7. Minus 7. It's going to give us one answer. 5 times 6 is 30. Plus 4 times 1 is. So our answer is XY. Sorry. $18 minus 7 is 11/47. 30 plus 4 is 34/47. So when you are solving a system, your solution is written as an ordered pair. So our ordered pair would be 11/47, 34/47. Please, by all means, double check my little simple math. Make sure I didn't over subtract or over add. But remember, we also learn how to solve systems using elimination and substitution. Remember those guys? And now you have another way. All right, questions, comments, concerns. All right, so that's solving a system using the matrix. Last but not least for this unit is word problems. Okay, on a new exercise program, your friend plans to do a run, jog, walk routine every other day for 40 minutes. She would like to burn 310 calories during each session. The table shows how many calories a person, your friend's age and weight, hours per minute of each type of exercise. So running 8 miles per hour, jogging, and walking. No. Start chewing some bubble gum. All right. So the first thing we're going to do is set up our matrix. If she's running in total, she wants to burn how many? 310. So we know that we're going to assign each one their own variable. Let's make X, Y, Z. So I know that if this was a system, it would be 8X plus, not 8, 12. We're talking about calories. Lo siento. I still want to write 8, and I don't know why. 12.5X plus 7.5Y plus 3.5Z equals 310, right? And she wants to work out how much? A total of 40 minutes every day, right? So she wants to dedicate 40 minutes every day to each exercise. So X amount of minutes plus Y amount of minutes plus Z amount of minutes has to equal 40. And she's going to jog twice as long as she runs. So Y equals 2 times X. Does the system that we have make sense? Okay. So at this point, because we do have a system, you could take the system and solve it by substitution, right? I could go ahead, plug in for Y, do substitution, do elimination, do all of that, have fun with it, go for it, right? So that is an option. The next option here is to show you that there is another option with solving matrix equation. Now, I've gone back and forth through variables, and I just feel like it takes too much time, and we're not that, it's not that necessary. But when we convert this to a matrix equation, I'm going to have to subtract 2x, and this is going to equal 0. So my matrix equation, remember, it's your coefficients, your variables, your constants. So my coefficients for the first one are 12.5, 7.5, 3.5. 1, 1, 1, -2, 1, and 0. My variables are X, Y, and Z. And my constants are 310, 40, and 0. Okay? So once it's set up at this point, we're actually just going to, you're going to get fairly excited. We're going to find the inverse and multiply using Desmos. So we're going to find the inverse of the 3 by 3 and multiply using Desmos. So we're going to go to Desmos matrix. I don't remember. I don't know why I'm having a brain fart. So we're going to look, we need the inverse of a 3 by 3. So we have a new matrix. It's a 3 by 3. And the values of our 3 by 3 are 12 and 5/10, 7 and a half, 3 and a half, 1, 1, 1, and 2, -2, No, -1 and 0. So that's our matrix A. To find its inverse, we're going to type A, then click the inverse. And that's A's inverse. Now we're going to put in matrix C, or it will B in this case, sorry. And it's a 2 by 1. I'm sorry, a 3 by 1. And the values that are in that are 310, 40, and 0. And we're going to hit enter so that it saves. And what you type in next is important. So order matters. So we have A inverse times B. Hit enter, and there's our solution. So we end up with 10, 20, 10. Yay. So when we come back here, yep, we know that 10, 20, 10, x equals 10, y equals 20, and z equals 10 minutes. So she needs to run for 10 minutes. She needs to jog for 20 and needs to walk for 10 to accomplish her goal. And that concludes our matrix unit. Questions, comments, or concerns?